Hello, everybody, and welcome. Great to have you with us. Just to let you know that this session is going to be recorded, so if you do want to listen again, then look out for the email, which will have a link to the recording, and we're planning to send that out tomorrow. So, introductions then. I'm Mark Forbes from Oxford Computer Training, Oxford Computer Group's specialist training team, and we're hosting today's webinar with John Craddock. Oxford Computer Group is a Microsoft partner. We specialize in identity, security, and enterprise mobility. We offer a range of Microsoft identity training courses for MIM, for Azure AD, including our new Azure AD Connect Masterclass. So it's my pleasure to introduce John Craddock, who's been involved in Microsoft solutions since the early days of Windows, I think. He's an international speaker, and incidentally, he's going to be presenting a week after next at Microsoft Ignite. But if you can't get to Ignite and you still want to meet John in person and benefit from his incredible identity knowledge, then you can always take his brilliant 5-day identity masterclass, which I'm pleased to say is now available in the United States and the United Kingdom. So we're delighted to have John with us for the next hour. I'm not going to do much of an introduction other than that, so let's get started. John, it's over to you.
Okay, well, thanks very much, Mark. And I was going to say good afternoon to everyone, but probably I should say good day because I have no idea where you are in the world. And thank you for attending this webinar. I imagine that most of you know that we were inviting questions up until last week to be addressed during the webinar. And thanks for a great number of great questions. I always work on the principle that all questions are good, and then there are the most amazing questions. The amazing questions are when the information is already included in the session and the details are coming soon. Majority of the questions classified as amazing. There were a few extremely good questions though, because as I say, all questions are good. And when we get to the technologies that are going to address the basis of those questions, I will hopefully provide answers. Okay, let's get kicked off. So the first thing to look at is where we are with Azure AD. And Azure AD is in the cloud. Microsoft hosts what we call tenants, or if you like, directories, and there are thousands of tenants and directories. Think of a tenant directory as being one of the same thing. What we have is once we have a tenant in the cloud, we're going to start putting our users in there. And how do we get our users in? Well, there are two management portals. There's a full-blown Azure portal in which there is a subcomponent of that for Azure AD and identity protection and other features. And then there's a cut-down portal as well. We could also use Graph API. Graph API gives us a programmatic way of creating users, managing objects within our Azure AD. Another option is PowerShell. And then if we've got on-premise AD users, then what we can do is we can synchronize those users from on-prem into the cloud. Once we have a user in the cloud and they authenticate using Azure AD, we can open them up to single sign-on to a whole range of applications. It could just be the Azure subscription, Office 365, applications from Gallery, and there are something like 3,008 applications in the Gallery ready to help you integrate. And of course, there's your applications you can deploy, and you can gain access to partner applications. If we look at what we need to do to evolve to the 21st century, we can think of our user who have for a long time needed to get an on-premise data resources, but those on-premise data resources have been in our bastion. It's been our Active Directory. We've been in total control of those users. But now, of course, our users are reaching out and we need to give them access to cloud resources. And then the question is, how do they get hold of data that's in a third-party cloud? How do we authenticate them to that data? How do we authorize them to that data? And then we bring in the need for a user-driven need for using any type of device. And I just had to include the Windows Phone. It's still there. I wonder if how many of you actually have a Windows Phone still. And then, of course, we need to collaborate, and collaboration is really key. So we'll be having users in from partner organizations, and they want to collaborate on our own resources. And then consumers. Consumers may be using a social identity of some kind that they want to gain access, and they may want to gain access, but we want to present access to information, and of course, in a very controlled and secure way. So we need to be able to build this identity solution. So really it's anything, which is any application, which could be on-prem, it could be in our cloud, it could be in a partner cloud, and we need to be able to control access to that. And we need to control it in a secure way. So we need to be able to authenticate and authorize users to those applications, regardless of where they are. Next thing is we have our users. Our users could be from our org, they could be from a partner organization, they could be a customer, and they're using any type of device. Where's the identity? Again, the identity could be from our own organization, and it could be from our on-premise AD, or they could be cloud-only users that just have a cloud identity. They could be from partner organizations. They could be from third-party enterprise identity providers, or the identity could be coming from social identity providers. This is our challenge. This we need to link together in a very secure way for gaining access to resources. And of course, it's federation that joins it all together. It's trust. Our applications are going to trust identity. And where are we going to trust identity from? We're going to trust identity from security token services, which are managing users' identity and issuing tokens. If we look at federation basics, what we have is a user who wants to gain access to an application. And our application is down there on the right-hand side, application X. So the user ends up going to a security token service and saying, please, can I have a token to prove my identity to application X? And the first thing the security token service is going to say is, are you authenticated? Now, if you're not authenticated, maybe the security token service can authenticate you, or maybe it sends you off somewhere else to get authenticated to another security token service. That other security token service would authenticate you, would then provide a proof of authentication. And the proof of authentication is the form of a digitally signed security token. But let's assume that our STS here in this diagram can authenticate us. So now our user is authenticated, and the next job it's going to craft a application or a security token for application X. And application X is going to trust that token. Well, actually, it'll do a number of things before it trusts it. Number one, it will be asking the question, is the token for me? Number two, it will say, is it from an issuer I trust? Okay, it is. Next thing, are the timestamps valid? Okay, they're good. Now, before we go any further, we've got the basics. Let's do a digital signature check of the whole of the token. And if that checks out, we'll believe the audience, which was for me, the issuer will now believe, the timestamps will now believe, and we can also believe other claims that are on that token. And what goes on the token, it really depends on the security token service as to what claims you can put on that token. There are options for requesting additional information, but how much real, the actual number of claims is going to be down to the security token service. If we look at the flow, what actually happens is the flow is, sorry, we'll just go back one stage. The flow is rather different to what I've shown in this diagram, and I'll come back to that shortly. But in terms of federation protocols, traditional protocols have been sort of SAML and very much used in the enterprise. From the Microsoft stable, it was WS Federation, WS Trust. SAML, very much still around. You'll find a lot of applications will use SAML protocols, their federation, and you'll also find that SAML is used extensively between identity providers. So two identity providers that share a trust, i.e. there's a federated relationship, may well be using SAML. But a couple of protocols that were originally consumer protocols are very much being adopted in the enterprise. There's OAuth 2, which is about delegation. It's about getting delegated access. So in terms of OAuth 2, what a user will do is consent to one application being able to access data that they are the resource owner for on maybe in a web API, and they are authorizing the first app to gain access to the data. So if someone says to you, what type of protocol is OAuth 2? It's an authorization protocol. And mainly it's used for delegated access, but there's other ways it can be used as well. And then for authenticating to a web front end, the protocol we'll be using there is layered on top of OAuth 2, and it's OpenID Connect. OpenID Connect, OAuth 2, very much coming into enterprise space, and you will find federation now between two identity providers. Rather than using SAML, some of them are beginning to use OpenID Connect. If we look at our actual flow from a browser, what happens is the user goes to a claims-aware application, and the claims-aware application checks if the user is authenticated. Well, if you're already authenticated, you will probably have a cookie, or Microsoft refers to them as session tokens. And we'll have a cookie, we'll present that to the app, and the app says, yes, an authenticated user. If you're not authenticated, the app redirects you to a security token service that it trusts. And there is a authentication string or a sign-in string, if you like, and in that redirect. And what it's really saying is, please authenticate this user and provide an access token. Well, actually, let's not call the name access token because I don't want to get mixed up with OAuth 2. Let's say a security token. Please provide a security token that will prove that user's identity to me. And that's the claims-aware application has actually set that redirect. So we authenticate with, in this case, Azure AD as our security token service, and we get a token back, which is then presented to the claims-aware application. Now, it doesn't matter. This is pretty much protocol agnostic. What will change is where we redirect to. So if we're redirecting to use SAML protocol, we'll be redirecting to SAML endpoints. If we're redirecting to use WS-Fed, we'll be redirecting to WS-Fed endpoints. And you've probably got it. If we're using OpenID Connect and OAuth 2, we'll actually be redirecting to one of two endpoints specifically for those protocols. The difference also will be the token format that comes back. If you're using SAML, WS Federation, it will be a SAML token. And if we're using OpenID Connect, it will be an ID token. And if we're combining OpenID Connect with OAuth 2 to get access to a backend web API, then it will be also include an access token. Now, when we look at today, well, how do we authenticate to front-end websites? You might use WS-Fed, you might use SAML, or the way the industry is going is to use OpenID Connect. When we go from the website to the backend web APIs, again, the industry is going towards OAuth 2. OAuth 2 has a lot of advantages in the fact that we can go with a delegated identity. The user can consent to the website using that delegated identity, and we've got control of token lifetimes. And there are things called access tokens, which prove our identities, well, authorize our access to the backend systems, but we also have refresh tokens that go with that. Now, we have to deal with lots of different application types these days. And one of the applications types could be a single page app, which is running Java inside a browser. And that's a very powerful way of running an app, because what it does, it gives us a very fast browser experience, but we need to go off and get data to render within the browser. And the way that we can do that is with OAuth 2. Again, native apps running on mobile devices going towards using OAuth 2. And then we have a server that is accessing a web API using the identity of the server. And one of the reasons for that might be that you want to trawl some backend web APIs with a daemon or batch process, and we're using the identity of the server, so not identity for user, there's no user involved, we're analyzing data on the backend. Again, OAuth 2 supports that. And then we could go from a web API to another web API using ACT on behalf of, again, OAuth 2. So lots of different scenarios that we have to address. Okay, I've mentioned a couple of times when we're using OAuth 2, a user can consent to the front end accessing the back end. Now, if we look at that consent screen on the left-hand side, it looks pretty horrendous. What we're asking the user to do is to consent to a whole lot of stuff they probably don't understand. And they might be tempted to click cancel, but then again, they want to use the app, so probably they'll click accept. At the moment in the Azure AD endpoints, what it does is it uses static permissions to go from the front end to back end systems. And what the user is presented with is a static consent, i.e. they're going to consent to everything up front. It's possible for an administrator to consent on behalf of all users, in which case a user won't be prompted at all, or we can look for the V2 endpoints that are coming out in Azure. They're a work in progress at the moment, but it means we can have dynamic consent. So the user doesn't have to be asked to consent to absolutely everything right at the beginning. And that's a real advantage because it takes the confusion factor out from the user. So a user can be said, hey, this app needs to log you on. Are you happy with that? And the user says, yeah, I understand that, and clicks accept. And later on, when the app needs to go and maybe access your calendar, the app can say, look, I need to access your calendar. Are you happy to consent to that? So we gradually build up the consent, and it remembers what the user has consented to. Let's do a very quick demo. And I'm using an app called OIDC2. This is one of the apps we use in the masterclass. And we're signing in with hybrid flow. And I'm signing in as an ordinary user, John. Needed to supply the password. And John is being presented with this consent screen. And notice permissions requested. And it's a bit daunting for the user. So as an alternative, what we could do is we could do administrative consent. An administrator can consent for everyone, so no users will be prompted. There is a button we can press in the UI, but it's another way is we can do it programmatically. So here we're signing with an administrator, and we're going to go just sign in, and this time notice it's permission request except for your organization. So here the administrator is going to accept for absolutely everybody. And I'm not going to at this stage not actually going to consent to that, but I just take you back to the app and just briefly talk about this for a second. So this is one of the apps that we use in the masterclass, and we can look at lots of different flow types. Flows are just ways of getting a token. So there's a hybrid flow, a code flow, an explicit grant flow, just an OpenID connect flow, and sort of client-to-client flow as well. So lots of, we go into great detail. The reason is we go into great detail because what I find when I'm working on a project, the developers will turn up with their latest app and want to deploy it. And they go and talk to the IT pros and they're saying, look, I need, I need a client ID, I need a client secret, I need this, I need that. And what happens is, before you know it, the developers are actually in your Azure AD putting their own app definition in. And what I like to see is the ability to have a discussion point. Are you sure you've done this the right way? Let's have a look at this. Let's see if this is the best, most secure approach. So we spend a lot of time really understanding this in the class itself. Remote access to applications. This is something else that we might want to do. And to do that, we're taking a web application that's on-premise. We can publish it out through the Azure AD application proxy. We don't need to implement a DMZ. We don't need to implement firewalls. It's all done for us. All we need is an outbound connection from a connector endpoint. And we can put in multiple connectors for fault tolerance and performance. Now, one of the things the app proxy is used for quite a lot is actually for publishing Windows Auth apps out. And the way this works is we publish the app out with a public URL. A user comes to the public URL, and the first thing we say is, to get through here, you need to be authenticated. And we authenticate the person with Azure AD. So that's actually using OpenID Connect. Having authenticated with OpenID Connect, we come through to the connector endpoint, and having got through to the connector endpoint, which is down here, so I can just mark that there. So coming through to the connector endpoint, what the connector endpoint does is it talks to a key distribution center. So it's talking Kerberos, and it's using Kerberos constrained delegation to get a Kerberos ticket with the identity of the user. And that is injected into the header. So now we're actually supporting Windows Auth apps out through a proxy, which before we can get through the proxy, we're using claims authentication with a Windows Azure identity. So let's just very quickly have a look at that. And we're going to the WA proxy here, and I'm going to sign in as my user, and it's going to be John. And we're going to, John is a user from on-prem AD. We're signing in, and we're going through the proxy. So this is now entering through the proxy in the cloud, and we've ended up and we're authenticating with Kerberos on premises. Another thing is we might have a forms-based authentication. So we've got an application that actually we need to put a username and a password in. Okay. One of the things we're trying to do is get SSO to absolutely everything. So in terms of signing in, what we can do is we can sign into Azure AD, and once you're signed in there once, you've got access to all apps which we authenticate to through Azure AD. So now what we do is we take out a password vault credentials that we inject into a browser. So that's password forwarding or vaulting, where it's held in a secure vault, and forwarding. So let's actually have a quick look at that. And so I'm going to go to an access panel, which is the My Apps portal. I'm going to sign in as a different user here, and this is my user James. And so this is taking James in. James happens to be a cloud-only user, and we're going in as James. And what James has got is a link to LinkedIn. So he's clicking on the link, and it's going to inject credentials in here. So I've no idea what we're going to see. I'm actually injecting it to my own LinkedIn page, and could be interesting. Maybe we shouldn't wait and find out. But okay, so we got one. Okay, that's not too terrible. All right, so this is how we've done injecting the credentials actually in to the browser itself. Access to 3,000 plus SaaS apps. Now, this is not like this is not like a store where we go and we get Box, we go and get DocuSign. This is an integration point. So access to integrating 3,000 plus apps. We've got three tiles at the top. The first one is about putting our own apps into the system, and we spend a lot of time putting apps into our system in the masterclass. The next one is about publishing on-prem apps. Again, we publish on-prem apps, we publish Claims app, publish Windows app. And then you've got non-gallery apps. So these are apps that are not in the gallery, but there's help to get them integrated. Now, if they're in the gallery, there's an awful lot of help to get you started with these apps themselves. Once you've put the app in, you can assign a user to the app, and they appear in the My Access panel. So as I say, it's about integrating apps and wizards to help you integrate apps rather than you choosing an app saying, I want that one. You've already bought the app, you've all bought, or you've arranged to have, let's say G Suite, for instance, Google G Suite. So there's an integration point of how to get G Suite into the system. And what's very, very important for us is the ability to assign and unassign users to applications. So when we say we're going to use G Suite, one of the things we'll need to do is assign a user into G Suite. Now, we could do that manually. Now, why do they need to be in G Suite? Well, imagine we hit a G Suite app. The first thing that's going to happen is going to say you're not authenticated, and it's going to redirect us to Google's STS. Google's STS needs to say, you're a federated user. I know where you come from. I'm going to send you to your Azure AD tenant. So we need the user up there for that reason. Secondly, obviously, we need users up there for licensing purposes. So we arrange to integrate in G Suite through the gallery. Okay, so we arrange a federation between Azure AD and G Suite. And actually it has it shows you how to go into Google and actually set up that federation. But equally well, we can turn on provisioning and deprovisioning. So now when we assign a user to G Suite within Azure AD, what actually will happen there is it will automatically assign a user into Google, into G Suite Identity Store in Google. That's done through a system called SCIM. And what SCIM is System for Cross-Domain Identity Management. Again, it's an industry standard and lots of people are now implementing it. And what Google will have is a SCIM server. So the provisioning can be done, and equally well, the deprovisioning. So you get a really nice end-to-end story, sign a user to an app in Azure AD and they're automatically provisioned into the target application. Types of users, cloud-only users. Well, we saw one cloud-only user. Did we really notice any difference in behavior? No. We can also have hybrid users. So the users with on-prem AD and Azure AD identity. And then we have external users with identity from another Azure AD tenant, a Microsoft MSA account, a Google account, and that has just gone into preview sort of a couple of weeks ago. We can actually use, we can actually bring in someone with a Google identity as an external user into Azure AD. And that's pretty exciting that that's lit up. And I expect to see lots more external identities in the future. But that's the starter and just gone into public preview. Now, who's in charge of authentication? Our tenant is responsible for authenticating cloud-only and hybrid users who are homed in our directory. If they're hybrid users, we might be doing a username and password check against our on-prem system, but we're ultimately in control. If we've got external users, right, the external users are authenticated by their identity provider. But then we can assign external users to our applications and groups. We can assign licenses to external users. We can impose conditional access policies on those external users. So we can decide, for instance, to trigger MFA for an external user if they are going to a particular application. And our tenant implements the MFA. Equally well, when they signed into their own identity provider, that may have required MFA. So they might end up with double MFA, but if they're coming to one of our apps, we might say you have to do our MFA to get to that application. Now, applications. Applications can be just sort of in our tenant, and usable by our own users and external users, or they could be a multi-tenant app. Multi-tenant apps are really, really powerful. What we can do is we can create a multi-tenant app. Having created a multi-tenant app, it can accept tokens from any tenant in the Azure space. So any tenant can actually authenticate to our multi-tenant app. And who can gain access to that app is not controlled by our tenant where it's registered. So it's shown here that the app is defined in tenant A. Who can actually gain access is controlled by the app itself. So now what happens is the app gets a token. It says, is it for me? That's the first question. If it's not for me, just reject it. That token has been bogusly played against you. Again, we'll be checking timestamps. And then is it from an issuer I trust? Well, it could be from A, could be from B, C, D, E, F, G, H, however many thousands of different Azure tenants. It could be from any of them. So you could let them all in, all right? Or you could decide, actually, do you know what? I'm only going to allow in tenants who have paid me a license fee. So we can control it on a per tenant basis. If you want to, you can get down to controlling it to per user basis in that tenant as well from a tenant. But it is the app that is in control. Now, if we do B2B, it's a rather different scenario. With B2B, what we're doing is we're actually inviting a user into our tenant. So this is an invitation process that happens, which can either be done through the UI, or we can do it programmatically, either using the Graph API or using PowerShell. We invite someone into our tenant. Having invited them into our tenant, they are going to be authenticated by their own tenant. So if our user John, who's invited from B into A, goes to access an application in A, then what's going to happen is John will be authenticated by B. But because they're an external user in A, we have a huge amount of control over that external user. We can force them to do MFA for our tenant. We can assign them to applications. We can assign them to license. We are in total control. If we don't like that user anymore, we just can delete them and they will no longer be able to access any of our apps. Now, one of the questions in particular Klaus asked was, is it safe to have external users in my directory from a security perspective? Well, from a security perspective, that user has been authenticated by a tenant we trust. If we don't trust them, why are we bringing them in? So we've trusted them to authenticate them to the level we need it. If we need additional authentication, we can put a second factor of authentication onto them. So we can do that. And then we can control exactly which applications they can gain access to. For instance, if you've got some sort of SAP application or something in the cloud, maybe you're using Workforce or Workday or something like that, then if you don't assign the user to that, they are never ever going to be able to use it. So yes, you can have really good security around that. If we just pop back to the multi-tenant app, you create an app and then basically anyone can gain access to it. Well, anyone can produce a token to that multi-tenant app. But the question is, it's down to the app to control who can access it. And quite a number of organizations actually publish multi-tenant apps in a second tenant. Right. If you're working with collaboration, then the concept behind B2B is about collaborating on apps that you're using in your tenant. So I hope that answered your question. So let's just have a look and see what we can see here. So I'm going to go up to Azure and I'm going to now go in and I'm going to sign in with Hybrid Flow. But this time, what am I going to use? I'm actually going to go in using a Google account. So I'm going to go across to xdsjohn@gmail.com. And next on there, that is going to now detect that we have a federated relationship with Google, and it's going to send me over to Google. And I arrive at Google, and there's the account that it's recognized, and we need to sign in on Google. And having signed in on Google, what Google will do is issue a token as proof of authentication to Azure AD, and then Azure AD will issue a token to the application. And this is our app. Our apps look pretty complex. We can use them as a really good harness for looking at everything. And we can see there that we actually have a Google IDP. So we've actually come from Google. So moving on from there, what we do in terms of enhancing security, we can assign users to applications and groups, we can require MFA, we can impose conditional access, and the conditional access can be very, very fine-grained as to, we can look at devices, whether someone's coming from, type of application they're running, and what application they're going to, and so on. We can also, one of the things about, security is about availability as well. We can arrange to set up a self-service password reset portal. Now, if we're using hybrid users, i.e. users where they have their passwords are being sourced from on-prem, then what we'll need to do is arrange for our hybrid users are going to require write back. So when we change the password, it'll get written back to on-prem. It's a synchronous write back so that any on-prem password policies that we have will apply. We can also benefit from banned password detection, which I'll come back on, and also leak credential detection. So if your credentials have been found on the dark web, they can be flagged as leaked. Now, for hybrid users which are sourcing identity from on-prem, for that to work, we need to use password hash synchronization. Now, conditional access and MFA. So I can set up conditional access so that for certain situations, I require MFA. I could turn on MFA for absolutely all users, right? And then they would have to do MFA when they log in. But here, what I'm doing is I'm setting up a condition whereby when they actually meet that condition, they are going to have to do MFA. So we can say who the policy applies to for the applications that's being accessed. If we're using identity protection, we can bring in the risk associated with the user, the device they're using, location, client app, and so on. But if you want the risk aspect, you need to be running identity protection as well. And then we put in a control, and in our control there, we're showing requires multi-factor authentication. Now, a question that came from Frank was, okay, I've done this, but the problem is these users are new to multi-factor, so they've never registered. And what can happen is there can be a considerable delay between putting this conditional access policy together and somebody actually hitting the condition where they need to use MFA. When they hit it for the very first time, they will be required to register for MFA. All right, but there can be quite a latency, and of course what you really want is your users to register for MFA fairly promptly after you've decided to implement it. Otherwise, there's a potential for someone, if you can actually hack the account password based, you could then the hacker could put in their MFA credentials. Well, I had an exchange of emails, and in that exchange, Frank realized that, in fact, you could put in identity protection to do the MFA registration. And yes, you can do identity protection and you can force MFA registration. You have a skip window whereby number of days you can actually skip before you have to register for MFA. That skip window used to be adjustable via control in the public preview. That's gone at the moment. Whether it comes back, I don't know, but it's generally considered 14 days you can skip for, and then you're forced to use it. Now, one of the things, of course, is you have to pay for the identity protection. You have to pay the additional license. And I was thinking about this. Is there a way of actually sorting this out? And what I did is I actually created an MFA policy to force everyone to register. And I had a group, okay? And I had a group, if you were in that group, you were forced to register for MFA because everyone had to do MFA for all access. And then, of course, they're immediately forced to register. And then what I was looking for is a programmatic way of detecting that they were registered. Unfortunately, for conditional access at the moment, programmatic access, API, PowerShell is very, very limited. So I couldn't find a flag that would tell me that a person had registered. And then what my plan was to, if they'd registered, I would take them out of the group that required them to do MFA for everything. Well, I did find a workaround, but I don't like it. What I did is I looked at the authentication phone number, and if that became populated, I could take them out of the group. But I don't trust that as a way of knowing for certain that they've done all the registration needed. So, sorry, at the moment, the only way is to go for to go for identity protection. But in the future, when we got programmatic access, I think I might revisit my my method. Okay, let's have a very quick look at this. So I'm going to go in to the access panel, and I'm going to go in as a new user. And this is my user David. And going in as my user David in here. And I'm going to have supplied a password for David. And having supplied a password for David, I'm into my access panel. Let's go to the portal. And on the portal, I actually have a conditional access policy that says you need to do MFA. So David is now being prompted for MFA. And I'm actually using a YubiKey as an authenticator. So 302340 is my code. So put in my code in here, 302340, and we should be authenticated into the portal. So instead of using an authenticator app, I actually used a YubiKey without notification to do my authentication for me. Okay, banned passwords. Password changes in the cloud are subject to checks against a Microsoft Global Banned Password List. Top 500, approximately, banned, most used passwords are banned, plus character replacement variations. So it takes a password, lowercase, looks at all upper lowercase combinations. It then looks at sort of standard replacements like O being replaced by 0. And an A being replaced by an at, and so on. Now, for a while, there's been the ability to create a custom password list can be created, and that has been around, as I say, for a while. It's now in the UI, and you could put in things like your company name and ban passwords based on the company name, project names, or your best or your worst boss ever. You could choose that as to ban the password. Now, this works beautifully when you're changing the password in the cloud. With a hybrid user, if you've got a password that's set on-prem, so on premises you reset the password, then you need to be able to detect the password change on your domain controller, and you need to actually check it for against the banned password list at that point. And Microsoft offer you a solution. It involves a password filter DLL and an agent to be deployed on every DC. And then we have a proxy, which is associated with as part of this product. We have a proxy that we install, which allows the agent to go off to the Azure tenant. And we only need one agent to go to the proxy per domain. And it goes off to the tenant, pulls down the banned password list, including your custom password list, so the global and your custom, puts it in sysvol and replicates it to all DCs in that domain. So you'll need a proxy per domain to actually pull that information. That's, if you're interested, I've done a blog on that. Have a look at the blog. Now, hybrid users. What we need to do is synchronize our users and groups, devices. We also need to do things like enable password write back, devices and group write back as well. The sync engine of choice is Azure AD Connect. We use it in the masterclass and to look at all the different ways of authenticating, but we don't go into the hardened detail of the sync engine itself. OCG, the Oxford Computer Training, now have a masterclass just on Azure AD Connect. I believe it's a 3-day. So if we're talking about on-premise user sign-in to Azure AD, there's a number of options. We can use password hash synchronization. And really, this is the best way of doing it. What happens is you take your password from on-prem and you push it up into the cloud. But it's not password synchronization, as which Microsoft initially called it. And when they initially called it that, people were thinking about password filter DLLs and taking a clear text password and pushing it into the cloud. Chief security officers threw their hands up in horror and said, no way. What actually happens is it takes the hash of the on-prem password, the MD4 hash, and it puts it through 1,000 iterations of HMAC SHA-256 before it puts it up into the cloud. So even if you could steal it, it's salted, it's a rainbow table state of work. Computationally, it would be very difficult to actually recover it. So it's really very safe, gives you a great, and password hashing absolutely needed for leak credential detection. It's really needed as a fallback for using ADFS if you're using it, and it's needed as a fallback for using pass-through authentication. So pass-through authentication came out last year about this time, and the idea is you take the credentials, gather them in the cloud, and pass them down to an auth-n agent, which runs on premises, and we actually authenticate against on-prem. And then the last one is federation. Of course, federation has been around for absolutely ages, and federation with ADFS. Here we go to log in, and Azure AD detects, does a home realm discovery and detects that actually we are from a on-prem STS. And what we need to do is we get directed down. Now, in terms of integration, ADFS is probably the simplest to integrate. There's actually in the Azure AD Connect, there's integration for ping as well now. But ADFS was a very popular solution. People are now moving away from ADFS, maybe to password hashing, possibly to pass-through authentication. But if your ADFS fails, you need a fallback position. And one of the ways to do it is with password hash synchronization. I say your AD fails. I've seen recently a complete on-prem, rather than ADFS failing, I've seen a complete on-prem AD fail. Okay, so our sign-in methods, password hash sync, pass-through authentication, which is referred to as PTA, and then we've got the ability of adding seamless SSO to both of those. Okay, let's just do a very quick demo of that. Now, seamless SSO today doesn't work with Edge, so I'm going to switch over to a different browser, and I'm going to use Chrome. And Edge support is coming, but it's not there at the moment, but expect changes soon. So we're going over to Google Chrome, and that should switch us all over. Now, do you remember we went to our proxy application and we had to sign in as our on-prem user, John at 5.ad? Let's try it again. So we're going to our WA proxy, and we are actually logged in as John to our on-premise network here. And this is not using ADFS. This is just using the single sign-on with password hash synchronization. And we've got true SSO now. So that's really been sorted out. So federation, what we do is we hit our claims aware application. It could be the portal, Office 365, whatever that app is. It redirects us up to Azure AD. It says, not authenticated. If we were authenticated, we pass a cookie to prove our authentication. So it does a home realm discovery. And we can do a home realm discovery. We can use, we can automate this process. We can use domain hints. Next job is having discovered our home realm. It says, you're federated, or Azure AD says, for your domain, I'm federated with an on-prem ADFS. So it sends you down to on-prem ADFS. Whether you hit the on-prem ADFS directly or whether you go through the WAP, it depends where you come from. We authenticate, we get a security token back, and we return that security token to Azure AD. That is proof of authentication of the user to Azure AD, not to the application. The application knows nothing about your on-prem STS. So having done that, we process the token and we return a token that can be consumed by your claims-aware application. So we send the token, and at that point, we can retrieve more information about the user. Of course, it relies on the directory being synced, and we can send back the cookies and the page. So we're now authenticated, and who authenticated us? It was our on-prem STS. And very typically, it's been ADFS. However, you can use different on-prem identity providers. Ping, Okta, well, Okta's actually in the cloud, Shibboleth, and there are more. If you do it, you need to maintain the federation, and that will include updating the signing certificate. At some point, the signing certificate that signs the token, let's just pop back there. This is the green token here that is returned. So this green token that's returned is going to be signed by your ADFS or your on-prem STS. At some point, that the signing certificate will roll. If you've had the problem that it's rolled, then you can update the federation settings in Azure AD. If it hasn't rolled yet, but you know it's going to roll in the future, and you know the new certificate, then you can update the MSO domain federation settings with the next signing certificate. So now you've got the current certificate and you've got the next signing certificate. So what will happen is when Azure AD goes to validate the certificate, if it's not correct, it will try the next signing certificate. So, Thomas, that was a question from you with the Shibboleth. I hope that's answered your question. And the last the question that we came up with was from Garrett. Now, Garrett actually said, what he wanted to do was have a sort of whatever situation. He wanted to craft his own authentication and exactly how the authentication workflow would work. And basically what you need to do is you need to develop your own STS, and then you can create whatever authentication flows you want. Now, the thing is to be very careful about this. Your STS needs to be highly secure. It needs to be highly available, right? And what's more, it needs to remain that way, and not everyone can do that. So I would say look for a third-party STS. If you want to just do certificates, ADFS will do it for you. If you want to do something completely different and matching your whatever and create your complete own authentication flow, then you are going to have to actually create your own STS. And just be careful, make sure it's really, really secure. Okay, so question is, what can you do next? Well, one of the things you could do is you could attend the masterclass. We actually go through pretty much everything in Azure AD. What we don't do are the easy bits. So I don't go into setting up identity protection, because actually identity protection is fairly easy to set up. Lots of videos, lots of help from Microsoft. So we're doing the difficult bits. So how do we get applications in? How do we manage all the protocols? In fact, we spend quite a lot of time on troubleshooting the protocols. Why? Because if you troubleshoot them, you then know what's required to get the protocols working. So in fact, we do that on the very first day of the course, day and a bit actually, and then by the time you finish that, you go, yes, I know, if I want to deploy an OpenID Connect app, what I need is the application needs to be configured this way for it to work, and then I will need to configure it that way in the cloud. You build your own Azure AD, and having built your own Azure AD, you'll take it away with you because you put it in your own subscription. You've got all hands-on labs, all the source files, all given to you. And what's more, you have a lab environment for 2 months after the event. A lot of people, they don't necessarily do all hands-on again, because that would take a long time. But what they do is they do demos based on our demo environments. And then having done that, they can demo to their colleagues, etc. It's available all over the place. The other thing is I'm doing 3 sessions at Microsoft Ignite this year. I'm doing an Azure Active Directory hybrid identity and band password detection. So looking at that, that's a theatre session, which is just a 20-minute slot. I'm then going to do a complete ID Pro guide to OpenID Connect OAuth 2, not only with the V1 endpoints, which is how it works today. And as we saw, we had the static condition, but I'm also looking at the V2 endpoints, where we can actually do, with the V2 endpoints, we can do what's called incremental consent or dynamic consent. That V2 is going to be very interesting when it finally ships. At the moment, if we want to put an application in, we need to put an application into a different portal. It doesn't go in the main Azure portal. We register it in the dev portal. But again, at some point in the not too distant future, I expect the dev portal and the Azure AD portal to be consolidated. And also, I'm doing a troubleshooting OpenID Connect and OAuth 2. So hopefully, if you're going to Ignite, I will see you there. Obviously, wave from the audience so I can see you. And what I'm going to do now is I'm going to hand you back to Mark, who can just tell you how you can contact Oxford Computer Training to find out even more. Mark, can I hand you back?
You can indeed. Great stuff there, John. Thank you very much for a terrific session and some really useful for insights there. And also thanks to those who submitted their questions. So before we wrap up, just be grateful if you'd spend a moment to answer the question that's appearing on your screen now, to indicate if you're interested in meeting John in person at his Identity Masterclass. As he said, the class is available now in the US and the UK, as well as the other locations that he spoke about. So feel free to register for that class. We'd love to see you. Remember also to look out for the email following this webinar, which will include a link to the recording of this session. It'll also include dates for all of our courses, including John's masterclass, and also details of any other webinars. So I think that's it, and we'll wrap up now. So from John and myself, thank you very much for attending today, and have a great day. Thank you.
Thank you for coming along.